I don't know about you, but I've become pretty addicted to my electronic devices. In particular, my network devices that communicate with each other wirelessly. The big problem with these devices, however, is that they actually use a lot of energy, even in standby mode. In fact, it was estimated that in 2013, all of the network devices in standby mode use more energy than the entire nation of Canada. So this is obviously a big problem, but physicists in my field of research have come up with some solutions that combines magnetic materials with electronic circuits. Now, these magnetic materials can be thought of sort of like thin sheets of materials that are made up of billions of little tiny magnets, kind of like the bar magnets that you find on your refrigerator. Now, what makes this useful is two facts about magnets that you probably already know. First, they have a north and a south pole, and that can be used as basically a 1 or a 0 in a computer memory. And second, magnets attract and repel each other, and that's an interaction that can be used to actually transfer a signal from one place to another. So to get these ideas out of the laboratory and into a product that's actually useful, we need to make them smaller and faster. Smaller in particular is very challenging because it's hard to study things that are small, and things get more complicated when they're small. That's where my research comes in. I've been working along with another graduate student in my group to use a new method of studying magnetic materials that uses heat. What we do is we locally heat a small spot on our material, and we get an electrical signal that tells us which direction the magnet is pointing at that specific point. By scanning this small point of heat around, we can map out a picture of what all of the magnets are doing. This is really exciting because you can focus heat to a much smaller point than you can focus something like light. And this will give us a high resolution image of what's going on, and therefore more information that can be useful to us. While this is a relatively new technique, we've already been able to use it to look at materials that would be very hard or nearly impossible to study otherwise. We've also been able to see how electrical currents interact with magnetic materials, and that's something that's really important if you actually want to use these for devices. Moving forward, I think that using heat to image nanomagnetism will be an important part in developing faster, more efficient electrical circuits and ultimately consumer devices that use less energy. Thank you.